Well, now that we're done with problem number one, you may understand why that would be an A-level problem. It's a difficult problem because you end up with fractional subscripts that you have to mend. But if you follow through with a consistent problem-solving um, methodology and an understanding of both the laws of definite composition and the law of multiple proportions, it's very doable. Let's take a look at another problem. Here we have three compounds consisting of two elements that are decomposed, and the following data is obtained. The first compound contains X and Y, and it has 4.4 grams, 0.4 grams of X and 4.2 grams of Y. The second compound has Y and Z. The amount of Y is 1.4 grams, and the amount of Z is 1 gram. The third compound is another compound of X and Y. In this case, X is 2.0 grams, and Y is 7.0 grams. We have our data. What we want to know then are three things. We want to know what are the relative masses of X, Y, and Z. We want to know what are the chemical formulas of the three compounds. And we want to know if we decompose 21 grams of compound XY, how much of each element is present. Now, there's a big clue in part C of this problem, because B asks what are the chemical formulas of the three compounds. One of them has to be XY. So that's a nice thing. And what I'd like you to do is to pause the podcast and try and solve this on your own and see how you do. And when you're ready to come back and look at the solution, just resume the podcast. Good luck. Welcome back. Let's see how you did. We're going to solve for part A first. And it wants to know what the relative masses of X, Y, and Z are. So what I'm going to do is look at X and Y. And because X has a lesser mass in both of these compounds of X and Y, I'm going to go ahead and make it the factor of 1 here, the ratio of 1. So I'm going to take 0.4 grams of X divided by 0.4 grams, which gives me 1 for X. Y will be 4.2 grams divided by 0.4 grams, which gives us 10.5 for Y. And essentially what that means is for every 1 gram of X in the first compound, there would be 10.5 grams of Y in that compound. In the second compound, we have 2.0 grams of X divided by 2.0 grams gives us 1 for X. For the Y, we have 7 grams of Y divided by 2 grams of the X, which gives us 3.5. So for every 1 gram of X in compound 3, we have 3.5 grams of Y. Now, because one of the formulas is XY, an assumption can be made here that compound 3 is XY because it has the closest mass ratio between X and Y. If you look at the first compound, there's 3 times as much mass of Y for every gram of X. In the third compound, there's just that 3.5 grams for every 1 gram. And so it's very easy here to deduce that if one of these has an XY formula, it would be compound 3 where the mass ratios are closest. So our conclusion is that the relative mass of X to Y is that it is 1 gram to 1 gram of X to every 3.5 grams of Y. Well, now that we've found the relative mass of X and Y, we can use the ratio of Z to Y to find the relative mass of Z. One of the things that we know is that there are 1 gram of Z for every 1.4 grams of Y in compound 2. And so all we have to do is set that relationship up so that I have my 1 gram of Z over 1.4 grams of Y is set up equal to X grams of Z over 3.5 grams of Y, knowing that 3.5 grams of Y is its relative mass. Now I'm going to rearrange this ratio to solve for X, and it ends up looking like a factor label problem, which is really a fine way to do this. So I take my 3.5 grams of Y and I multiply it times that factor of knowing that there is 1 gram of Z for every 1.4 grams of Y. That's a ratio, but we call it a factor oftentimes. Now, the grams of Y will cancel. We're left with grams of Z, and we get 2.5 grams of Z for our relative mass. So our relative mass is 1 gram of X for every 3.5 grams of Y for every 2.5 grams of Z. So we have solved for problem A. I hope you were successful in that, and this is a good way to do it. Well, let's look at the solution to part B. On your slide, you're going to notice that it got relettered part A. Would you change that to B? Because we're really working on part B. What are the chemical formulas for the 3 compounds? Now, we have only enough information on the compound containing Y and Z to conclude that its formula is YZ. We don't have any other way of finding any other relationship there other than that it is YZ, so we're going to be content with that. And then we're going to use the mass ratios of Y from the first and third compounds so that we can determine what their formulas are. And we're going to take the 10.5 grams of Y from compound 1, divide it by the 3.5 grams of Y that would be in the second compound when we look at the relationship between 10.5 grams of Y for every 1 gram of X in compound 1 and 3.5 grams of Y for every gram of X in compound 3. When we do that, we get a whole number 3, so we can make the conclusion that our formula for compound 1 is XY3, and our formula for compound 3 is XY, which we had already determined. Well, all we have left to solve for is part C. Here it is. If you decompose 21 grams of compound XY, how much of each element is present? Well, one of the things that we know is that there is 1 gram of X for every 4.5 grams of XY. The reason I know that is there's 1 gram of X for every 3.5 grams of Y, so the total relative mass of the compound XY has to be 4.5 grams. So there's 1 gram of X for every 4.5 grams of XY. It also means there are 3.5 grams of Y for every 4.5 grams of XY, using the same logic we did earlier. We're going to use ratios to determine how much there is. So I set up my 1 gram of X for every 4.5 grams of XY equal to X grams of X for every 21 grams of XY. I solve my ratio for the X value. So I have 21 grams of XY times my ratio of 1 gram of X over 4.5 grams of XY. My grams of XY cancel, and it leaves me with the conclusion that there are 4.7 grams of X in 21 grams of XY. So if I completely decompose 21 grams of XY, I should have 4.7 grams of X. For Y, we use the same approach. 3.5 grams of Y over 4.5 grams of XY is set up equal to X grams of Y over 21 grams of XY. We then solve as we did before, so 21 grams of XY times that ratio of 3.5 grams of Y for every 4.5 grams of XY, and we get 16.3 grams of Y. So if we decompose 21 grams of compound XY, we'd get 16.3 grams of Y and 4.7 grams of X. How'd you do? If you had problems with this, it might be a good idea to use the relevant data, cover up what you tried to answer before and anything that I helped you with, and try and solve this problem again. See if you can work your way through it. Again, this is an A-level problem, typical of what you'll see in a rigorous general chemistry course at the university level. We've come to the end of part 3 of our video podcast series on the use of mass ratios in chemistry. This was the A-level problems part of it. Part 1 had to do with the law of definite composition applications. Part 2, the law of multiple proportions applications. I want to leave you with a wonderful quote from Alexander Solzhenitsyn, famous Russian novelist and dissident. Literature transmits incontrovertible, condensed experience from generation to generation. In this way, literature becomes the living memory of a nation. I wish you well.